All right, guys, a couple of questions were asked about the last three problems on the 10.7 worksheet. Now, I'm happy to do these, but I will point out this 10.7 worksheet was due by the end of the day yesterday, so it would have been great to get these questions a couple of days in advance so I could have worked them out and you guys could have had this done before you turn that in. But anyway, better late than never, so let's talk about what's going on right here. On this 10.7 worksheet, we have ourselves circle R, and then we have radii here drawn from R to P and from R to Q. And this little wedge right here, the shape of a piece of pie that I've shaded in red here, is called a sector. And they want us to find the length of arc PQ, basically the crust of that pie or that pizza. They want us to come up with the length for that. So trying to keep things in order right here, I always tell you guys to begin with a formula for what it is that we're trying to find. We are looking for the length of an arc, and the formula for arc length that we learned a while ago is that S, and for no good reason that's the variable we usually use for the length of an arc, is equal to theta over 360 multiplied by 2 times pi, that's an awful pi, wow, 2 times pi, let's try that again, times the radius of your entire circle. Remember that 2 pi r is the formula for the circumference of the entire circle, and theta is the measure of the arc in degrees. So theta over 360 tells us the fraction of the circle that we're interested in. 2 pi r is the radius or the circumference of the entire thing. So there's two things we need to know, and neither one of them was given to us at the beginning of this problem. We need to know theta, which is both the measure of this arc in degrees, but also the measure of this central angle right here as well. So we need to know that, and we also need to know the radius of this circle. And I think maybe some of these things were found in the previous three problems, but I'm kind of starting from scratch on this one. So we're just going to use these two pieces of information right over here. The area of the entire circle was 295.52 square inches. The area of just the red shaded sector is 55 square inches. Okay, so what that tells us now, guys, there's something going on right here. We now have the smaller area right here compared to the entire thing. So if I think about the formula here that we discussed a while ago for the area of a sector, okay, let's play around with that for just a second. Let me switch colors on you right here. We'll go to purple on this one. Okay, so the formula for area of a sector is similar to the formula we just wrote down for arc length. It's theta over 360, but now we multiply it by the area of the entire circle then, which is going to be pi times the radius squared. Unfortunately, let's see, there's a few things going on right here. We can probably figure out the radius here first. Let me go just to this formula right over here for a second, guys. Area of an entire circle is pi times your radius squared. We know that the area of this entire circle is 295.52, but we don't know the radius. But we can kind of work this formula backwards and figure that out. The first thing I would do right here is divide both sides by pi. Okay, those pi's cancel out, and that tells us then that r squared equals, and they gave us decimals here, so we're definitely going to need a calculator here, 295.52, and that is going to get divided by pi. And when I hit enter here, that now gives us 94. I'm just going to write down 94.07 here. Okay, so 94.07, but let's not get ahead of ourselves. That's not the radius. That's the square of the radius. So to undo that square, we need to take the square root of the left and the square root of the right. So moving over here to the side, that's going to tell us now that r is equal to, and let's try this again, guys. We are going to do the square root of the last answer, that 94.07. And we end up then with a radius of, boy, still not something very nice. I'm going to go with a 9 point, looks like that would be 9.70 if we rounded that to the nearest hundredth. So that is our radius right there, guys. The radius is 9.70. That's some information that we're going to need in order to figure out what's going on here for the length of that arc. But the other thing we need is theta. And so to do that, I think I've got to go back to this formula right over here. And now that we know what r is, let's see what we can do. I tell you what, I'm going to change this color here. Let's see how I can do that here. Change that to green. And let's keep running with that underneath right there, guys. So filling in what we know within that formula now, we know that the area of that sector right here is 55. Okay, we still don't know what theta is. Over 360 multiplied by pi times our radius of 9.70, and we're going to square all of that. All right, this is complicated and kind of ugly, guys, but that's a formula that we can solve, or an equation we can solve. Unfortunately, though, I think I might need a new page right here in order to do that. So let me just copy that, start a new page right here, and we'll paste this up at the top and see where we can go from here. Okay. As far as this right side, what I think I'm going to do here is leave the left side alone at 55. And on the right side, I think I'm going to multiply the pi times the 9.70 squared, and I think I'm going to divide that by this 360 right down here on the bottom. So here's how I'm going to do that, guys. We are going to multiply, where was I? All right, we are going to multiply, nope, I went to the wrong spot. Here we go. Pi multiplied by my radius, which is my previous answer squared. So there's the pi r squared, and I'm going to divide that by the 360 that was on the bottom of that fraction. And that gets me a 0.82 for a decimal there. That's going to be the coefficient of theta on that right side. All right, so that's now going to become a 0.82, but the theta still is going along for the ride. And the last thing we need to do now is to divide both sides by 0.82. And that then will cancel out with that, and it should tell us the value of theta here in all of these 6 problems right here. So 55 divided by that last decimal that we just got. 55 divided by last answer. And that tells us that theta, okay, this at least worked out pretty nice. Even rounding that to what? The nearest hundredth right there, we get 67.00. So I think that's how they actually designed this problem. I think they started with theta being exactly 67 degrees, and then you figured out everything from there. Okay, so boy, that took a lot of work, but we now know the value of theta. And let me go back a page. We know the value of r. So back to where we were right up here in blue. We were trying to come up with the length of this arc. I think we now know what we need. So arc length is equal to 67 over 360 multiplied by 2 times pi times a radius of 9.70. And it's ugly, but I think we can just dump all of that directly into the calculator and get our answer here. So let's try this, guys. All right, so our formula here is 67 divided by 360. Let me hit the right arrow to get out of that, and then we're going to multiply by 2 times pi, and then multiply that by our radius, which I think, can I go back and get this here? I can't do that, so I do have to type this in manually, guys. We said 70, we'll go with that. So 9.70 for that radius right there. And that should do it. Theta over 360 times 2 pi r should get us our answer here of 11.34 for the length of that arc there. 11.34. Since everything here for area was being measured in square inches, we know that we're just in inches here for the length of that arc.